Hello everyone and welcome to today's video. Today we are going to explore how to integrate OAuth 2 login with ZBD in Unity project using beamable microservices. We'll guide you through setting up beamable, creating the necessary microservice, and implementing the login flow in Unity. Let's start with explaining OAuth 2 briefly. OAuth 2 is a widely used authorization framework that enables applications to obtain limited access to user accounts on HTTP service such as Facebook, Google, Microsoft, and in our case, ZBD. This framework allows users to grant third-party applications access to their information without revealing their credentials. Understanding how OAuth 2 works is crucial for securely managing user authentication in your applications. Here's a simplified breakdown of how OAuth 2 works. The app asks the user for permission to access their resources on service provider. If the user approves, the app gets an authorization grant. The app exchanges the grant for an access token and a refresh token from the service provider. The app uses this token to make an API request on behalf of the user. The app accesses the user's information from the service provider's API using the access token. If the access token expires, the app can use the refresh token to get a new one without needing the user to log in again. Now that we have a basic understanding of OAuth 2, we will see how to leverage beamable microservices to manage the OAuth 2 login process securely and efficiently. Beamable is a powerful tool that simplifies backend operation, making it easier to implement secure and scalable solutions in your Unity projects. However, you don't have to use Beamable. This can be your own server. You can use your own .NET or Node.js server or any other backend technology. By the end of this tutorial, you will have a clear understanding on how to use Beamable microservice to implement a secure OAuth login with ZBD in your Unity project. So let's dive in and start building. First, you need to set up Beamable in your Unity project. If you haven't set it up already, you can follow these tutorials or the official documentation for installation and initial setup. Once Beamable is set up, we need to create a microservice called login server to handle the OAuth 2 follow with ZBD. Within this microserver, we will handle all the breakdowns of how OAuth 2 works that we talked about earlier. We also need to create a side script called OAuth login for managing the OAuth 2 login process on the client side of the Unity project. Let's start with microservice login server. Inside this microservice, we have a method called generate auth URL. Within this method, we create the auth URL required for ZBD login. It uses Pixie for enhanced security and stores necessary parameters like the verifier and state in beamable stats. In this method, we start by generating Pixie codes, which consist of verifier and a challenge. We then create a unique state value to track the user session. These values are stored in beamable stats for later use. Next, we retrieve the redirect URL and client ID from beamable config. Finally, we construct the auth authorization URL using these parameters and return it. Next, we handle the login callback within the continue login method. This method processes the authorization code received after the user logs in and exchanges it for an access token. In this method, we first retrieve the beamable configuration. We check if the URL contains the expected redirect URL, extract the authorization code and state from the URL, and then retrieve the verifier from beamable stats. We call getAuthAccessToken to exchange the authorization code for access and refresh tokens, passing the code, verifier, state, client ID, client secret, and redirect URL as parameters. Inside the getAuthAccessToken method, we create an object with the required data for the token request. We serialize the request data to JSON and create an HTTP content object with a JSON string. We then send a POST request to the ZBD token endpoint and read the response content as a string. If the response indicates success, we deserialize the response content, extract the token and expiration time, and call getUserData to fetch the data using the access token. We return the tokens and user data if successful. Within the getUserData method, we set the authorization header with the access token and add the API key from the beamable config as a header. We send a GET request to the ZBD user endpoint, read the response content as a string, check if the response indicates success, and deserialize the response content. If the response contains an error, we extract the error message and return it. Otherwise, we return the user data. Back in the continue login method, After calling get auth access token, we check if the token exchange was successful. If it is, we store the tokens and expiration times in the result and save the tokens in beamable stats. We deserialize the user data and store it in the result before returning the result in a JSON format. If the token exchange was not successful, we return an error message. In the save token details method, we get the current Unix time in seconds and calculate the expiration times for the tokens. We create a dictionary with the token details and save them in beamable stats for later use. Now let's talk about the check token status method. This method, in general, checks if the user's access token is still valid. If it is expired, it uses the refresh token to get a new access token. It retrieves and updates token details and fetches the user data, ensuring the user stays logged in or prompt them to log in again if necessary. Let's break it down. Within this method, we first define the token fields to retrieve from beamable stats. Then, we check if all required details are available. We create a token stats object with the retrieved token details. Then, we get the current Unix time in seconds. Then we check if the access token is still valid. If it is, we set the login status and token details in the result and fetch the user data using the access token. If the access token is not valid, we use the refresh token. First, we check if the refresh token is still valid. If it is, we use it to get a new access token and a new refresh token. We fetch the user data using the refreshed access token and return the result in a JSON format. The refresh access token method is designed to refresh the user's access token using a valid refresh token. This process involves sending a request to the auth provider to obtain a new access token and a refresh token. Let's break down the method step by step. We first fetch the client ID, client secret, and redirect URL from beamable config. These settings are necessary to make the token refreshed request. Then, we create an HTTP client instance to send the HTTP request. Then, we purge the request data as a dictionary, specifying the grant type, refresh token, client ID, client secret, and redirect URL. We convert the request data dictionary and send the post request to the ZBD token endpoint. If the response indicates a success, we read the response content and deserialize it into a dynamic object. Then, we call save token details to store the new access token, refresh token, and their expiration times in beamable stats. Then, we create and return a login result object containing the new tokens and their expiration times. If the response indicates failure, we return a login result object with an error message. Now, let's go back to the check token status. If the token refresh is successful, we fetch the user data using the new access token and return the result, including the new tokens and user data. Now that we have covered the server-side microservice, let's move to the client-side script and how we use all this method inside the server side. This script is responsible for initiating the login process, handling the response, and displaying the user data. It communicates with the beamable microservice login server to perform these tasks. Let's break down auth login script. Let's start with awake method. First, we set up the deep link handling. The deep link activated event is used to handle deep links, and the method checks if the application was opened with a deep link URL. In the start method, we use player prefs to check if the game has been opened before. If it has, we call check login status to verify if the user is already logged in. If the game is being opened for the first time, we set a flag in player prefs to indicate that the game has been opened before, so this check will recognize in the future launches. Within the check login status method, we check if the user is logged in. We communicate with the beamable microservice login server to check the token status. We purge the result and handle errors. If the user is logged in, we display the user data and show the logout button. If not, we prompt the user to log in and we show the login button. This eliminates the need for the player to log in again if they are already logged in and the tokens are not expired. The start login method initiates the login process. We set a response message indicating the start of the login process and call the generate auth URL method on the login server microservice to get the auth URL. If the URL is received successfully, we open the URL in the browser. Next, the continue login method is called when the ZBD authentication server redirects back to your application with the authorization code. This redirection happens via deep link, which your application must handle to continue the login process. The continue login method processes the deep link URL, extracts the authorization code, and exchange it for an access and a refresh tokens. It calls the continue login method on the login server microservice, passing the deep link URL and the player ID. The server-side continue login method processes the URL, extracts the authorization code, and retrieves the token and user data. The result is serialized into a JSON string, which is deserialized into a login object. If the user data is successfully retrieved, the method populates the UI element with the user's license address, gamer tag, access token, refresh token, and their expiration times. It also sets a success message. If the user data retrieval fails, an error message is displayed. Now, let's talk about the onDeepLink activated method. The onDeepLink activated method is a part of the Unity's engine's application live, and it uses it to handle deep links. A deep link is a URL that links directly to specific content with your application. In the context of OAuth 2, deep links are used to redirect back to your application with the authorization code after the user have authenticated. The method takes a single parameter URL, which is the URL that was used to deep link back into the application. This URL contains the authorization code and other relevant information. The method then calls continue login with the received URL. Here's how the onDeepLink activated is set up and called. In the awake method, we subscribe the onDeepLink activated method to the application deepLink activated event. This means that whenever the app is opened via a deep link, the onDeepLink activated method will be called automatically. When the onDeepLink activated is called, it passes the URL to the continue login method for processing. Now, here's a summary of the overall flow. The user initiates login by clicking the login button, which calls start login. Then, the client calls generate auth URL on the server to get the auth URL. The user authenticates with ZBD, which redirects back to the application via deep link. Unity triggers the onDeepLink activated event, calling the onDeepLink activated method. The onDeepLink activated call continue login method, which processes the authorization code and retrieves tokens and user data. The continue login method updates the UI with the retrieved user data and tokens. In summary, by following these steps, you can successfully integrate OAuth 2 login with ZBD in your Unity project using beamable microservices. This approach ensures secure handling of user authentication and management of access and refresh tokens. Now, let's move on testing the app. First, we need to build the app and ensure that your beamable microservice is deployed and accessible. Then, launch the app and click on the login button. This will trigger the start method, which generates the auth URL and opens it in the browser. In the browser, log in with your ZBD credentials. Upon successful authentication, ZBD will redirect back to your application using the deep link. Your application will receive the deep link, triggering the onDeepLink activated method. This method calls continue login, which processes the authorization code and retrieves tokens and user data. If the login is successful, the continue login method will update the UI with the retrieved user data, such as the license address and the gamer tag. Now, let's close and reopen the app to test the check login status method. This method checks if the user access token is still valid and refresh it if necessary. Ensure that the user remains logged in without needing to re-authenticate. When we click on the logout button to test the logout method, this method clears the stored tokens and updates the UI to show the login button. Note that users have the ability to manage their signed-in app directly from the ZBD application. If a user revokes these tokens, the player will need to log in again to grant the necessary permissions. Don't forget to add client secret, client ID, and API key inside beamable config. For more information about the login with ZBD process, you can visit our documentation on our website. That concludes our tutorial on integrating OAuth 2 login with ZBD using beamable microservices in Unity. Thank you for watching, and I hope you found it useful.